So you can look at the clock right here. It's 3:05 a.m. So why not do some math? All right. So here we have the first one, solve for x. It's got fractions and how you fear these things. But the first thing I would do if I were you is I would clear the fraction by multiplying both sides by 7. All right, so we introduce a 7 over here. If I introduce it over here, I better introduce it over here because that's kind of how that works. So the 7's on the left-hand side will disappear. So what do we have? We have 2 times 4x minus 5 is equal to 8 times 7, which is 56. The next thing I would do would be to divide by 2. Actually, let me repeat that. You can do one of two things. You can divide by 2 or distribute, and most will distribute. Most will. So if we distribute, we'll have 8x minus 10 equal to 56. Next thing you should probably do is add 10. 8x is 66. And finally, divide by 8. So x is 66 over 8. And that'll reduce. Those are both even. 66 and 8 are both divisible by 2. So that's 33 over 4. Not a hard problem. Here we have absolute value. And we're going to do something similar here. We're going to clear the fraction. I'm going to multiply both sides by 4. So the 4's on the left will disappear. We'll have 3 absolute values of 8x minus a 4 equal to, we got to multiply both sides by 4. 4 times 7 minus 3x. And let's see here. We can also, at this point in time, distribute the 3 and the 4. So distribute the 3 on the left. We'd have the absolute value of 24x minus 12. Because you can distribute into absolute value. That'd be equal to 28 minus 12x. All right, what do we do here? We're going to write two equations. The first one is as is, and we have an obvious mistake in this problem, don't we? No, we don't. The first one is 24x minus 12 equal to 28 minus 12x. Or the second one where the stuff on the interior changes, which was for some reason just so hard for y'all to grasp. I don't get it. I don't know why you struggle with that so much, but you do. Now we're just going to solve for x. So if I shift this negative 12x over, it'd be positive 12 and 24 is 36. If I shift this negative 12 to the right, it'll become positive 28 and 12 is 40. So x is going to be 40 over 36. Those are both divisible by at least 4. 40 over 4 is 10. 36 over 4 is 9. Kind of the same mythology here. If we add 12 to both sides, we'd have a negative 12x. 28 minus 12 should be 16, so x is a 16 divided by a negative 12. Those are also both divisible by 4. So if we divide 16 by 4, we'll have 4. We're going to move the negativity up top. 12 divided by 4 is 3, so x is negative 4/3. Moving forward, solve this thing for h. So I just want this guy by itself, and the easiest thing to do is to move this piece over here for starters, all right? This, by the way, is the surface area of a cylinder, like a can of Coke or something. So if we move that to the other side, its sign is going to change. Well, that's under Greek, isn't it? Sorry, I was having a moment of struggle there. And what's going to be left on the right-hand side is 2 pi RH. I'm not at school, so I can't, I don't have my little writing pad. So I got to type all this stuff out. Now, 2 pi R is attached to H through multiplication. And the opposite of multiplication is division. So divide it out. It's really that hard. Some of y'all just have not figured out the common sense of mathematics. It's not that bad. It's really not. I'm just going to divide it by 2 pi RH. Sorry, 2 pi R, because I want the H all by herself. There we go. This is like easy peasy lemon squeezy right here. The hardest part about this is me actually having to type it all out. And it's done. That's how hard the question is. It is, it's done. So ta-da. All right, here's the ACT stuff. What is the equation of a circle centered at -9, 12 with a radius of 7? So standard form of a circle from geometry, which is a class you passed to get to me, is x minus h quantity squared plus y minus k, also quantity squared, equal to r squared. You get h and k right here. That's where you get them. So plug in. If we take away a -9, or if we think about the idea of inserting into a set of parentheses, we change our signs. I know that's not what y'all want to do. Y'all just want to let everything be the way it is. And then we're supposed to, of course, square the 7. Well, that's the answer if I just square the 7. Circles are like super easy. Super duper easy. Anyway, 7 times 7 has always been 49. Find the sine of angle B for the triangle below. So here you're thinking about SOHCAHTOA. And the sine ratio for any angle is the side opposite over the hypotenuse. And I wish I had a stylus or something here, because this is just going to be a pain in the butt to type. I'll try to use my little cursor here. So the sine of B, of course, first off, we have the issue of, do kids know the difference between opposite and hypotenuse? This is your opposite side. It is opposite of angle B. This is the hypotenuse. It is opposite of the right angle. It is also the longest side of this triangle. This is not hard stuff. I'm trying to use my fat finger here, so forgive me. Sine of angle B would be 5 root 3. Didn't put you over the hypotenuse of 10. And you know that 5 over 10 reduces to a half. At least you better. So root 3 over 2. Easy peasy, lemon squeezy. All right, rewrite the quadratic in vertex form into standard form. And here's the quadratic. It's 3 times x plus 4 squared minus 8. And, you know, the first thing Jesus would do is he'd write x plus 4 twice. and then FOIL. All right. X times x is x to the second. If you follow my cursor here, x times 4 is next, so plus 4x. Then inside, plus another 4x. And then last, 4 times 4 has always been 16. We still have the minus 8 floating around. We're going to clean up the interior here. I think 4x and 4x adds to 8x, although it's pretty early in the morning. And then we're going to distribute the 3. 3 times x squared is 3x squared. 3 times 8x is 24x. 3 times 16 is 48. And finally, I can actually combine 24x and, 48 and 8. And I should end up with something like this. Again, easy peasy, lemon squeezy. I got some basic function notation. You're given two functions here, f of x and g of x, because in part 6 you're going to figure that out. So f of negative 3, again, there's still kids that miss this, but it just blows my mind. So let x equals negative 3 in function f. So f of negative 3 would be 5 times a negative 3. I mean, seriously, some of y'all are missing this kind of stuff. Like, what is wrong with you? This is 5 times negative 3 is negative 15. We take away 7 from that, we get negative 22. So f plus g of negative 3 is literally f of negative 3 plus g of negative 3. Now, you already have f of negative 3. It's going to be negative 22. But you got to find g of negative 3. And how do you find g of negative 3? Well, you let x be negative 3 over here. 4 times negative 3 is negative 12 minus 5, which is negative 17. So we got negative 22, and we have to add to it negative 17. And negative 22 and negative 17 is negative 39. So there you go. I should probably write that out properly. Ta-da! All right. Find the average rate of change over the interval from negative 1 to 2. Of course, your formula for average rate of change is the same as it's always been. It's f of b minus f of a sitting pretty over b minus a. And of course, you get a and b from this guy, from this interval. So let's find f of b by plugging in a 2. We'd have 2 times 2 squared being 4, 3 times 2 being 6, 2 times 4 is 8, 8 minus 6 is 2. And while we're at it, we'll find f of a. F of a happens by plugging in a negative 1. So let's see here. 2 times negative 1 squared is going to be positive 1. A negative times a negative is a positive. And 2 plus 3 is 5. And then we just plug into our little formula. So we found f of b to be 2. We're going to take away f of a, which is 5. And we're going to be sitting pretty over b minus a, which is 2 minus a negative 1. Also easy peasy lemon squeezy. Or easy peasy Japanesey. I don't know. 2 minus 5 is going to be negative 3. And that's sitting over 2 take away negative 1, which is 3. And negative 3 over 3 is negative 1. Oh, I'm bored. Stuff's too easy. Number 9 is a zero product problem. It's going to be missed. I don't understand how you got to be a junior and you don't understand a zero product property. Anyways, we get to use ZPP. So by the zero product property, 3x plus a 2 is a nothing. or 2x minus 5 is a nothing. So this is a simple two-stepper. Subtract 2 from both sides, divide by 3. X is negative 2/3. Will kids miss this? Yes, lots and lots of you will miss this. And you'll be like, well, I don't understand why I'm failing. Because you don't know anything. And you need to start knowing things. Anyways, there's your answers. Negative 2/3 and 5/2. Find the roots, also known as solutions, or the x-intercepts of the zeros of g of x equals x squared minus 9x plus 8, preferably by factoring. So are there factors of 8 that add to negative 9? By golly, there are. X minus 8 and x minus 1. Negative 8 times negative 1 is positive 8. Negative 1 plus negative 8 is negative 9. And we're going to use the zero product property. So x minus 8 is equal to 0. We solve that one. We get x equals 8. Or the other factor, x minus 1 is 0. And if we just add 1 to both sides, that one is solved. X is 1. Number 11, solve using the quadratic formula. So let's see here. It's x equals negative b plus or minus square root b squared minus 4ac all over 2a. And again, I'm having to do this not at work with my stylus and stuff, just my fat finger. Now, the problem with this one from the get-go is it's not in standard form. So we're going to have to shift that 2 over to the left-hand side. And now it is. Hopefully you're not that kid who can't figure out A, B, and C. But do those kids exist? Yes. Lots and lots of kids did not answer the quadratic formula question on the last test. It's not like we didn't have days of practice with that thing. So I don't know. I'm going to plug in. Opposite of a positive 4 is a negative 4. Plus or minus. Square root parentheses if you're a button pusher. 4 squared minus 4ac. A is 3. C is 2. It's all sitting pretty over twice of 3. So in this radical, we've got 16 minus, oh, wow, it's imaginary. 4 times 3 is 12, times 2 is 24, so there's a 16 minus 24, which is a negative 8. I know it's not. It was negative 2. I almost made a mistake there. Look at that. That's 16 plus 24, which is 40. Bad Milbrath. 2 times 3 is 6. So that whole root 40, because I know that this bothers kids. I don't know why I can't type over there. Root 40. Interesting. Try that here. Root 40 is a root of 4 times a root of 10. And a root of 4 is 2, so 2 root 10. All right, that's what I'm thinking. I notice a lot of y'all just can't simplify radicals. I don't understand how you're coming to me with all these deficits. Like, are you not bothering to learn things? Negative 4 over 6 is going to be negative 2/3. We have a plus or minus symbol. This was 2 root 10 over 6. And 2 over 6 reduces. 2 over 6 is 1/3. Ones are understood in mathematics. So root 10 over 3. There we go. Ta-da! 12. The following is known about function f. F of negative 3 is 0. F of 4 is 2. F of 5 is 0. F of negative 7 is negative 5. F of 0 is 0. So this does bother some kids, but we can form factors from zeros. So I'm just going to go ahead and throw this guy away because it's not a zero. I'm going to throw this guy away because it's not a zero. And let's think about what this is. This is x equals -3, which as a factor is x plus 3, because what happens when you enter parentheses? It changes. There's another one that says x equals 5. As a factor is x minus 5. And there's another one that's x equals 0, which as a factor is x minus 0, which is just x. All right, we also have in the text a leading coefficient. A is always the first thing we ever talk about. So function f is the 3. Here's a factor of x, which I'm going to erase that parentheses. Then there's a factor of x plus 3 and x minus 5. And that is the answer. It's not a hard problem. Now my favorite section, the key features of a graph. State the domain. This thing runs from -6 to 4, and then it's got a hole. Bracket on the -6. There's a hole at 4, so I have to jump it. So union with 4, and then I'm still running right all the way to 2. And then I really have to jump this guy down there. And then I'm running from 2 to 7. So fairly complex domain for some. Range, this is our values of y. By the way, that's what, and I always forget that. I assume you know that. Domain is values of x, range is values of y, or your output. We have a low value of -3, and even though there's a hole here where y is 0, it's filled by this piece. And we rise all the way to 3, and I know you guys see these open dots, but it's solidity right here. So the domain is simply -3 to 3, or sorry, the range. And these are brackets. I know you guys get all hung up on the open dots, and it confuses the living daylights out of you, but these open dots for y are filled here on this line segment. Say the intervals where the graph is increasing. The graph is increasing from -6 all the way to 3. You can make an argument about this, but it's also increasing over here. So let's go -6 to, -2. And I guess technically we should say -6 to -4, union with -4 to -2. And we're also increasing from 2 to 7. All right, decreasing. It's not. The graph never goes downhill. So what we do is we create a small interval. And we insert a character into that, the null character, which I don't know if I can actually type on this software. I don't think I can. Huh. Okay, maybe I can, I'll just steal an image off of it. This is on the last quiz. There it is. This character right here means null or empty set. I'm sorry this is taking so long. That would be what I answer this question with. Where the graph is constant. You know, you guys know y equals a constant, right? It's a horizontal line. Most of you do. Some of you haven't figured that out yet. Your constant from x values of -2 to 2. State the x-intercepts. This blows my mind how many kids can't find an x-intercept. But there's one right here really close to 4. There's a hole there. So 4 comma 0. And what's throwing kids off is ordered pairs. The y-intercept, there's one right here. Kids will get this backwards all the time at 0, 3. Determine the average rate of change over the interval from -6 to +2. So I'm going to put a nice dot here where x is -6, and I'm going to put a dot over here where x is 2. And then I'm going to think about what happened. I rose 1, and I ran, count the blocks, and I think you'll realize if you count 8. So I rose 1 and I ran 8. My slope is 1/8. Find f of 2 if it exists. If it does not exist, state why. So when you look where x is 2, there's a hole here and here. It does not exist. There's a hole in the graph. In both places. Find f of 4. F of 4 does exist. And it's 0. Let's see, if f of x equals -2 were graphed, what solutions would there be to the system? So that's a horizontal line. If I graphed a horizontal line, it'd look like that. You don't actually have a solution here because there was nothing on the graph right there. So you have a solution right here. And there would just be one solution. We'll have to kind of guesstimate the x value here. We'll say like -5.3 or something like that. Now, if you want the true ordered pair, which is probably what I would do, I would say x is -5.3 and y is -2. Those are the solutions to the system. And from here on out, it's bonuses. So given f of x is 3x squared minus 4x plus 6 and g of x is 2x plus 1, find fog of x. What weird notation is that? This is f of g of x. That notation you should be familiar with from Algebra 1. I know it's taught. And that means let every x in f be g of x, which is 2x plus 1. So let's see here. That x is going to get replaced with 2x plus 1. It's squared, so I'm going to write it twice. I see an x. It's also going to be 2x plus 1. Then I have a 6. So if I do the FOIL method or double distributive property on 2x plus 1, I would have 4x to the second plus 4x. Make sure you understand that. And if I do the distributive property here, I'll have take away 8x, take away 4, plus 6. Use the distributive property, there will be a 12x to the second, plus a 12x, plus a 3. Now let's see here, we have a -8x and we have a +2. We combine -4 and 6, and I'm still combining with terms here. There are 12x squareds. I see a 12x and a -8x, so that's going to be plus 4x. And then I have 3 plus 2, which is 5. Easy peasy, lemon squeezy. All right, here we have fog of -2, and this is f of g of -2. And what we're going to do is we're going to find g of -2 and then plug that into f. We're going to work our way out of parentheses to some degree is what we're going to do. All right, so what is g of negative 2? It is going to be 4 times the negative 2, take away a 2. 4 times negative 2 is negative 8. Negative 8, take away 2 is negative 10. And since this is literally, I'm literally using the substitution property here, that is going right there. That's what's happening, bruh. All right, so f of negative 10 is next. That's going to be 2 times the negative 10 to the second plus 4 times the negative 10 minus a 3. Let's see, a negative 10 squared is 100. Then we have minus 40 minus 3. We have 200 minus 40, which is 160, minus 3, which is 157. Here we have what's called the difference quotient. Unless you take bridge math, I mean, you're required to know this next year. So you may as well figure it out. I'm going to start with this piece right here, this f of x plus h. That means that every x that I see becomes, forgive me, becomes x plus h. And it's squared, so I got to write her twice. All right, moving forward, x plus h times x plus h is going to be x to the second plus 2xh plus an h squared. I have this minus 3 times x plus h, which is negative 3x minus 3h. And cleaning this up a little bit more with the distributive property, I have 2x to the second plus 4xh plus 2h to the second, and then minus 3x minus 3h. I also have this piece right here, and a lot of kids really just messed that piece all up. That's negative f of x, so let's figure out what it is. Negative f of x, and the reason kids forget it is they do stuff like this. They say minus 2x squared plus minus 3x, which is wrong. It's minus all of that, and there's a lot of kids who just make that mistake. 2 or more things always wrap, and you won't be wrong unless you make a mistake in the distributive property. But it's negative 2x squared plus 3x. So let's line up this formula here. I'm supposed to take that guy right there. I'm supposed to take away, or actually, I'm supposed to put this in here, take away f of x, which is this. And it's all sitting pretty over the letter h. All right, let's clean this thing up. We have a negative 3x and a positive 3x. Gone. We have a positive 2x squared and a negative 2x squared. Also gone. See how that works? So what's left is a 4xh, and I'm going to change the order here, minus 3h plus a 2h to the second power, and it's all sitting pretty over h. Notice that all 3 of these pieces have an h. We got at least one h, we have an h, we have an h, and there's that h. So I can divide that h out, and I'll get a reduced form, 4x minus 3 plus 2h. That's the difference quotient, also known as the derivative of that polynomial. And what will we have to do? I thought there was like an ACT bonus here. I know there is. Apparently I went too far. This is it. There it is. That's the one I'm looking for. All right, so how do I do this thing right here? I do this thing through just rote memorization. Of course, I tell you what I is, and I to the second is -1. I cubed is -I. I to the fourth is 1. And notice it talks about I to the fifth. I to the fifth is I to the fourth times I, which is 1 I, or just I. Okay, so what's this thing clean up to? The top is I, because I to the fifth is I, plus I cubed, which is -I, plus I squared, which is 1. The bottom is -2 times I squared, which is -1, plus 5 times I to the fourth, which is 1. And then I just kind of do some basic math here, I add like terms. Let's see, I have I minus I, which is nothing, plus 1, which is 1. Here I have 2 plus 5. Think about that. That's 2 plus 5, which is 7. It's not a hard problem. And that is your basic 6 quiz. And that quiz is Friday. Boy, that was a long video. It's nice when I can write. I can do this a lot quicker. Anyways, I hope you enjoyed. It's now 3:43 in the morning. Good day.